So the foundation for the polar system is called the polar axis. And in general, just like it has been with trig, just like it has been with vectors, the polar axis is the positive x-axis is essentially where we're going to start. So what we've got is the origin, or the pole is like the origin, okay? The polar axis is like the positive x-axis. The pole is like the origin. So this would be our pole, and this would be, we call them rays. When you got a point and then an arrow on the other end, that's called a ray, just like our vectors. Okay, so you're going to see a lot of similarities between polar stuff and vectors. That's kind of why I do it right after we've dealt with vectors. All right, so here is what we really need to focus on here. A point P in the polar coordinate system is represented by an ordered pair of numbers. Okay, instead of being an X and a Y, this is going to be R and theta. R represents the radius, the length of that segment. Theta represents obviously the angle. And it's measured just like our angles are always measured. You start on the polar axis, or if you want to refer it to something we're familiar with, the positive x-axis. So start at the polar axis, aka the positive x-axis. All right, so like I said, R is the radius, theta is the angle. So our angle is right here, theta is right there. This length is the radius. Just trying to give you as many reference points as possible. The picture, the words, the point. Okay, so let's actually get to plotting these points and what it looks like. So here's what your polar coordinate system looks like. This is what the polar coordinate system looks like. So it's kind of like your X and Y axis, but really it looks a lot like the unit circle, doesn't it? We start at 0. It has the angles labeled, the special angles. Now, these are not the only angles that we can use. They're just the most common ones that will be used. And each circle there represents a radius of 1. Okay, each circle there represents a radius of 1 unless it is otherwise labeled. So here's how we're going to graph these first. You start by finding the angle. Okay, so step 1, you find the angle. So for the point 3 pi over 4, okay, we are going to be graphing somewhere on this segment right here where pi over 4 is. The radius is 3, so we're going to start at the pole there in the very, very center, and we're going to count out 3 of these circles. So 1, 2, 3. This is where that point 3 pi over 4 is located. So you find the angle first, then you count, I guess, the number of circles. Count out, let's just do this. Count out from the pole. Okay, example B, -3, 225 degrees. Well, we don't have 225 degrees on our graph here. Does anybody know what that is in radians? Anybody remember 225? 5 pi over 4. Okay, 5 pi over 4. So we find 5 pi over 4. But here's what that -3 is going to do. We start on the segment 5 pi over 4, but negative is going to shoot us through the pole to the opposite side. So we keep going along this line right here. Now, I don't want you to well, you can draw this line like this, but this isn't actually part of the graph. I'm just trying to illustrate to you. We start on 5 pi over 4, but the negative shoots us through to the other side. So that's where this point is. So guess what? It's the exact same point that we just had in A. Okay? 3 pi over 4 is the same as negative 3 225 degrees. Okay, those are actually the same thing. So a negative radius, I'd make a note of this somewhere, a negative radius, for lack of a better term, I'm just going to say it shoots you through the pole. To the other side. I think that makes sense, phrased that way. Okay, so let's look at example C. -1, negative pi over 4. So we got a lot of negatives to deal with here. Remember our hint, if we had a negative angle, the easiest way to locate where that was to find the positive angle, and then you just go directly below it or directly above it. So 7 pi over 4 is the same angle as negative pi over 4. Okay, you're going the same distance, you're just going clockwise instead of counterclockwise. But then it's also a negative angle, so we're actually going to end up over here at 3 pi over 4 is going to be the angle where it's located, and you're on the first radius there, the first circle. Okay, -3, negative 270. Okay, negative 270 degrees is the same as positive pi over 2. And if we've got -3 there, we go all the way back down here. So it's almost, not always, okay, not always, but in this case, it's kind of like the negatives cancel each other out, because we ended up in the same spot we would with +3, +270. But the same thing didn't happen over here, okay? -1, negative pi over 4, we didn't end up at pi over 4, +1. So don't think that is true in every scenario, okay? Don't think it's true in every scenario. All right, so let's